You got a big spot. Nice. I'm Robert Cosi, I'm the publisher of Canadian Contractor, and we are here again at the ITW warehouse where they have a test facility here for the fasteners that they make, and I'm with Andrea. And I'm with Andrea Galindo, and she is a technical specialist for ITW, and she does a lot of testing on the screws and the fasteners that they make here. So, Andrea.
Correct.
You're teasing me about it now. Okay, Andrea. Now, what's this test called, and what are we going to see here?
So this is a pull test, and we use this to test the withdrawal force of an assembly. So in this case, we have the GRK screw. It's a 3/8 by 4 inches RSS GRK screw into wood.
Mm-hmm. What should we expect? What kind of results should we expect?
So in this case, we want something around 800 pounds force, approximately. Okay. Our machine will test in kilonewtons, and remember 1 kilonewton is approximately 225 pounds of force.
I will never remember that.
Yeah, you can Google that.
I can Google. That's a good point. Okay, so what we'll see here is a reading, and then you'd have to translate that into pounds.
Force.
Pounds force.
Yeah.
Okay. So so how does this work? What's going to happen?
Right. So I'm just going to take the wrench, and then I'm going to start applying some torque to our machine. This is a hydraulic machine, and you're going to see an increase on the force in this dial.
Okay.
So we'll put our safety glasses.
Right. All right, here we go.
And then I hold this.
Okay, and I'm going to read these numbers here.
You're going to read this.
1, 2, 3, 4, 5, 9, 8. Oh my God, 21. Holy smokes! It's going up. It's going crazy. 59. I can't keep up.
9, 10.
Okay.
11.
Yeah.
11.5, and now it's decreasing. So that means that the maximum load was 11.5 in this case.
Okay, I was reading them upside down. That is a problem. So 11, it read 11.5. So the strength of the screw, or the resistance of the screw, is being read here. And so as the number rises, you can see how much resistance the screw is creating.
Correct.
And then when it drops, that clearly indicates that that's the maximum.
That's the maximum, right? So that's going to inform us what is the strength that the threads are engaging into the wood itself.
Mm-hmm. Okay, so it read 11 on this scale here. What does that mean in terms of pound force?
In terms of pounds force, it's about 2,500 pounds force.
Really?
Yeah.
So what was the design level for that?
Right, so it varies. It depends on the threaded length and the embedment of the GRK screw into the wood itself. Mm-hmm. In this case, we want to have approximately something in the range of 850 to 1,000 pounds force.
Okay, so again, we've got a massive safety factor built into this screw.
Right, and this is because the values that we're publishing are as per our Canadian standards.
Okay, so that's a Canadian standard, 800 to 1,000. That's what this screw should hold, and we just tested it at 2,500.
Correct.
Okay, so tell me, like, what part of the manufacturer makes the screw stronger or weaker when it comes to this test?
Right, so it's a combination. The threads are extremely important. The diameter of the screw is important, the threaded length, and the embedment of the screw itself. For a simple screw that you will find like this, there's a lot of science behind it. There's, of course, some studies done to ensure that what is the maximum angle or the effective angle that we need to ensure maximum holding or withdrawal force. We have a specific gravity for every single type of wood, and then that specific gravity will affect the withdrawal force or the tensile strength of the wood.
So even different kinds of wood will give you different values when it comes to the pull-out strength of a screw or whatever.
Correct.
Okay. If you've got any specific questions about the construction of these of ITW screws, or any screw for that matter, please send your question to the email address at the bottom of the screen. We'd be happy to answer them. Thank you very much, Andrea. That was very interesting. I appreciate your time.